Hi, I am George and I will demonstrate the binding system. This is a demo scene from Polygon Starter Asset by Cinti. I will try to simulate a car engine by using an oversimplified model of it. The car engine is the script used as an example for this demonstration. I will simulate the entire car movement with just this script. This is the code for the engine. It is pretty basic but requires many parameters to work with it. We have the parameters section, the input section, and the output section. The logic is pretty basic, as you can see. Now back to Unity. Let's start playing and test this script. I have some UI elements here which do nothing for now. In the inspector, the gas pedal position is being changed and the car starts moving. I can even shift gears. Oh great! Now suppose I need to change the values for a specific car, say a Toyota Yaris. And there are many alternatives how to achieve this. One, you can change the values by hand, but this can become exhaustive. Two, maybe create a manager with the polymorphism and apply changes from predefined objects. It involves code development and it's not very suitable for a non-programmer. Or use the binding system and let the designers decide where to get the data from. With a simple code transformation, all inspector values become bindable. We can go from this code to this code. When refocusing Unity window after a bind code transition, the user is prompted to transfer the data from unbound values to bound ones, thus avoiding any data loss during transition. The inspector view remains largely unchanged, except for these tiny hexagons. I will go in play mode and check if everything works as before. When changing values, the behavior is exactly the same. The blue hexagon indicates that this field can be bound to another value. When clicking on it, the view changes and allows the user to bind it from a source object and a path to a property. Now, suppose I want to assign the value for input parameter load from this rigid body mass. I drag the object and select the mass property using the Smart drop-down menu. This script gets the input from the keyboard. The spacebar is used for gas pedal and number keys for gears. I will try to bind this script to our car engine script. Drag the keyboard controls over bind source, click on path, and select gas pedal position. Now I redo the same actions for selected gear parameter. Now let's test this new changes. So if I press spacebar, the car starts moving, and if I press the number keys, the car changes gear. But what if I want to see the raw values that are passed in? Let's activate the live debug. You can see the values changing, flowing now. Well, the live debug will show the values passing at each phase, from its source to its user, going through converters and modifiers. It will also show exceptions throughout data phases. Now let's suppose I want to use other control methods. I will enable the UI game object, which has a bunch of basic UI controls. This is a speed value label, a gear shifter slider, and a gas pedal slider. If I test play this, these elements do nothing. This could be a perfect fit for my car controls. Let's go ahead and rebind the car engine input parameters. When I replace the bind source, an error will appear letting me know that the selected path is not compatible with this new source. Change the path and repeat for the selected gear. Notice that the selected gear is an integer, but I can pass a float value from the slider. This will automatically add the converter for this bind field. Now let's bind the speed value, which is the output of the car engine script. The binding of a value can happen both ways, reading and writing. I will bind the speed value to the label so we can see it in the UI. When I press the bind arrow button to switch the write-only mode, I am immediately given a write converter, where I can specify the string format I want. I think it's enough only the first two decimals. Okay, let's test this out. Now, the car moves when I interact with the UI elements. Even gear shifter works correctly. Awesome! Now, the gear label, however, doesn't change. This is because I'm yet to bind it. Now, I want to see if the converters work as expected. Let's activate live debug for the selected gear and the output value. Okay, now I change some values, and you can see those reflected in the converters. You can already see the write converter applies the formatting just before sending this data to the source. So far so great. I think I want to change the color of the speed when pressing the gas pedal. For this, I will need to add modifiers. A modifier allows to manipulate the values just before returning it to the user. I've just added a propagate modifier to current speed. This will allow to further propagate the values. We add a target, and we enable the bind mode here for the first target. Then I drag the speed value label and propagate this value to its red channel. This to turn it red when having high speed. This is also a perfect occasion to bind the selected gear label, to have a feedback directly in the UI. I do the same thing as before, but first let's search it. I need to find it. It should be in the same panel as the gear shifter, if I remember correctly. Okay, and here it is. Let's bind it. First, drag it. Great. Then select the text property of the text mesh pro. And once I select it, oh look, there is a new converter in town. Great. Time to test it. Changing values seems to work. Even the gear label works perfectly. Let's see the reddish color of the speed value. It should only change for non-negative values, as you can see. Awesome. There is, in the hierarchy, a game object with long and short gear sets. I can assign one of them for my car. I drag it, click on the path field, select car gears and better short ones. Okay, that's great. Maybe I could change the max power of the car as well. Here I have a set of scriptable objects holding some important car data. Ferrari will do for now. Drag it and select engine max power. Any Unity object can actually become a source for bind fields. Mono behaviors, scriptable objects, textures, anything, you name it. Okay, so far so great. Now let's see how the system handles multiple objects. I duplicate my car. Yay, 2 cars now. Maybe it's better to split them. Great. Now when selecting both of them, I can still see my bind fields and make batch change maybe. How about changing the max power for both cars? I drag a Mercedes and assign its mass to both cars. Now let's do a final test to see these changes in action. Great, now both cars are moving. Awesome. In conclusion, with binding system, any value can be bound, even interfaces and non-serialized objects. It also allows for a very powerful and completely agnostic modularization. It can be used as well as a special dependency injection method. And that's all, I guess. Hope you enjoyed. Cheers, everyone.